Hi everyone, and today for controls we are going to talk about cruise control of a car. So let me start with an example. So let's say we engage the cruise control function of a car. So cruise control, and we want to target a speed of 20 meters per second. So first, let's create an equation for the motion of a car. So according to Newton's second law, the net force of an object equals its mass times acceleration. So what does this mean? The net force, we'll call this F, is equal to the mass of a car times its acceleration. And we know that acceleration is a rate of change of velocity. So this is distance over time, or dv over dt. Sorry, velocity over time. Anyway, and now we have various forces acting on the car. So these forces are the force of the engine for pushing the car forward, as well as friction from the road. So we can create the equation, the net force, m dv over dt is equal to the engine force of the car, we call that Ft, minus friction. So this will be bv friction or drag force. So engine and friction. So what does this equation look like? Well, it looks like a differential equation. So to make it easier, I guess, to do this problem, we will rearrange this into standard form. So this will be m dv over dt plus bvt over, is equal to ft. Now we have various variables here. So vt is equal to the vehicle speed, ft is equal to the engine force, m is the mass of the car, and we'll give this a value of 1000 kilograms. We have the road friction called B, and this will be 50 Newton second per meter. And then we also have our initial condition, and for this particular example it will be a velocity of 0. So what does this mean? It means that we start from rest. So just say starting from rest. Great. Now there's one more thing let's take a look at, the time constant. So what's the time constant? Well, in this particular example, the time constant is basically how fast the cruise control reacts. So to find the time constant now, we divide throughout by m plus b over m vt is equal to ft. And this is standard form, and b over m is equal to 1 over the time constant. Therefore, the time constant is equal to m over b, which is equal to 1000 over 50, which is equal to 20 seconds. So what does a larger or smaller value mean? Well, a larger value means that the car takes longer to reach our target of 20 meters per second, and a smaller time constant means it's quicker to reach our target value. Anyway, let's move on to our next step. So let's sub in our values of the mass of the car and friction. So let's go down here and we get 1000 dv over dt plus 50v is equal to 1000. Extra zero. Good. And also let's put our initial condition. The velocity when the time is equal to 0 is equal to 0. Now, why are we doing this and what exactly are we trying to find? Well, we're basically trying to find an equation for the velocity at a particular time. Anyway, the next step now is to take the Laplace transform. So, we know that the Laplace of dv over dt is equal to svs minus v0, and the Laplace of 1000 is equal to 1000 over s, and the Laplace of 50v is equal to 50vs. So now we just sub in these values. So that'll be 1000 to svs minus 0 plus 50vs is equal to 1000 over s. And now simplifying this, we get 1000 s bracket here plus 50 into vs equal to 1000 over s. And now simplifying further, making vs the subject of the formula, we get that vs is equal to 1 over s into s plus 0.05. And now from here we can do partial fractions, and well, this is equal to a over s plus b over s plus 0.05, and when we solve for a and b, we get that a is equal to 20 and b is equal to negative 20. So this will be equal to 20 over s minus 20 over s plus 0.05. And now we have this vs. We can now take the inverse Laplace transform. So I'll write that down. So taking the inverse Laplace transform, we have that v t is equal to 20 into 1 minus e minus t over 20 meters per second. And now what does this result mean? Well, what this equation means is essentially, given a particular time, we can calculate what the velocity of the car would be at that time. So for example, let's say we start at t equals 0. Well, we can calculate that our speed will obviously be 0. So speed is equal to 0. And the reason for this is because our initial condition is 0. If our initial condition was something else, it would be that initial condition. But now let's say our time is equal to our time constant is equal to 20 seconds. Well, our speed would be 12.6 meters per second, and this would be 63.2% of our target. And basically anything that's one time constant away will always be 63.2% of our target. But anyway, this was a very simple explanation of control systems given the control system of a car. And yeah, well, hope you understand. Let me know what you think or what you'd like to see explained better, or if I did anything wrong. But yeah, that's it. Thank you for watching.